Okay, if you're still working on your homework check, you need to pay attention, okay, and follow along with me. Okay, what we've got to do is we've got to take this calculator out of the normal mode and put it in press to test mode for new testing requirements. So right now, if you notice, there's a little light right here. See how it's not flashing? That means it's not in press to test mode. So what we're going to do is we're going to get it in press to test mode. So everybody needs to cut your calculator off. So to cut your calculator off, if it's on, you go to Control Off. All right, now it's off. So what we do now, okay, in order to put it in press to test mode, is hold the escape and the on or the home button simultaneously. Hold them and press them down together. So both fingers are going to press them down together now and hold it. And your screen would cut on. When your screen cuts on, you should see this where it says press to test. Do y'all see that? Okay. We've got to tab through. Hit tab, tab, tab until I get to enter press to test mode. Right, which I think it was already on there. And then just hit enter. So it'll say saving. You see the clock going on? And then it's going to reboot. Everybody follow those directions? Okay. If you did it, and if it's in that mode correctly, what's going to happen is, after it cuts back on, see my light? That's flashing? It's flashing red until it starts to be all the way in press to test mode. Then it's going to flash amber if you did it correctly. Okay, so give it some time to reboot. Everybody there? If you're still working on your homework check, just make sure you get it to me, turn it into the front while we're going over our notes. Okay, but I need it as soon as possible. Okay? Close your Chromebooks. I don't want that open. I shouldn't have a Chromebook open. Alright, so what we're going to do while this is getting in press to test mode, alright, what we're going to do is we're going to begin our notes for today. So everybody should have a copy of the 8-3 Day 2 notes on transformations of functions. And we've already looked at this type of problem yesterday, so this is just a quick review. Describing a combination of transformations. So if I have a function in the full vertex form, where I have an A term, where I have an H term, and I have a K term, you have to describe everything that happens in this transformation. So the A value is a -3. So if we describe the steps of the transformation, the very first thing the negative does is it reflects it across. It takes that U-shaped curve of the parent function, because every graph that we make on quadratics and linear functions are nothing more than a transformation of its parent. So it takes this parent function, this U-shaped curve that's pointing up, and the negative makes it do what? Reflects it across the x-axis, and now it's pointing down. So the negative reflects it across the x-axis. And then what does the 3 do to it? After it's been reflected, right, it's pointing down now, the 3 makes it more narrow, which is called a vertical stretch. So the 3 stretches the graph vertically by a factor of what? 3. What happens next? What's that +4 inside the parentheses do to it? It's inside parentheses, so that's left to right movement, right? So it's going to move it which way and how many spaces? Left, how many? 4. So the graph is then translated horizontally, which means left to right, to the left 4 units. Then translated vertically, which means up and down, by the K value. If that K value is positive, it moves it up. If that K value is negative, it moves it down. So what is that? It's positive, so it moves it what? Vertically up. How many units? 2 units. Just remember inside the parentheses, that's left to right movement. And it's kind of tricky because if it's positive, you think that would move it right, but it doesn't. It's always kind of the opposite inside of there because that's what we're actually subtracting. I took x minus a negative 4. So my h value here is really a negative 4 because x minus a negative 4 is the same thing as x plus 4. So what if I ask you this? Where's the vertex? How easy is it to find the vertex of this? Yeah, it's the h value and the k value, so it'd be a negative 4, 2. And what if I said, what's the axis of symmetry? What would that be? So where would that cut the U-shaped curve in half? If it's this U-shaped curve that's been narrowed, that moves to the left 4 and up 2. Where would that vertical line that cuts it in half be? It's the same thing as the x-coordinate of the vertex, so it's just negative 4. You got it? All right, see if we can do that in this problem B. What steps transform the graph of y is equal to x squared to the 1/2 times x minus 2 squared minus 1? Well, the a value of 1/2 does what to the graph? What does a 1/2 do to the parent function here? If my a is normally a 1, now it's a 1/2. What does it do? It makes it wider, which is a vertical compression, which means it's going to make it wider. So it's like compressing it, pushing it down, which is going to open it up by a factor of 1/2. Then it's translated which way? To the right, how many units? 2. So it's translated, it should be 2 right here. It's translated 2 units to the right. Sorry about that. And then it's translated where? 1 unit down. So it's translated 1 unit down because that's a negative right there, that negative 1. So where's the vertex if I ask you that real quick? It'd be at a what? Positive 2, negative 1, because I subtracted a positive 2. We good? You can put that here if you're done. Okay. All right, so let's look at the next problem 4. Applying transformations of quadratic functions. Now, if y'all did everything right on your press to test mode, okay, you could just say okay. So it'll come back on the screen and it's kind of flashing green. Just go to OK. And then there you go. Is everybody's flashing green? I thought it was amber. That was my mistake. So now everything's in press to test mode. Really doesn't change much. Okay, we'll talk about what it changes later. But for right now, we got to do that. All right, let's look at problem 4. Applying transformations of quadratic functions. A company makes satellite dishes with cross sections that are modeled by a quadratic function. So what that's saying is that if I were to graph a quadratic function, it's in the shape of a bowl, which is kind of a U-shaped curve, which is a parabolic curve. Make sense? Okay, so like dishes, like that we eat out of, soup bowls, salad bowls, all that other stuff is kind of made from a model of a parabolic function. Okay? So what is the equation that models this? That's what we have to look at. And it says the parent function f of x is equal to x squared models the cross-section of a satellite dish. Oh, so it's just the parent function. So what that means is that it has a point at the vertex, which is 0, 0. If x is 1, 1 times 1 is 1, so we have a y-coordinate at 1. If x was 2, we'd have a y-coordinate at 2, or 2 squared, which is 4. Right, so there'd be a point up here at 4 if that was the case. Right, if x was 3, then it would be 3 squared, so y would be 9. So it would be a U-shaped curve kind of going up if that continued on. It says the satellite dish is 1 foot deep. That means that if I were to make this into a bowl-looking shape, from the very bottom of the bowl to where this little imaginary diagonal would, or diameter would be, has a distance of 1 foot. So it'd be right there. You understand that? And then it says the radius of this bowl, so that means from the center to the outer edge of the bowl, if I could imagine that being a circular bowl inside, from the center to the outer edge is a 1 foot radius. Do y'all follow that? So if I kind of drew a little three-dimensional figure of the bowl, from the middle of the bowl down to the bottom is 1 foot, and then from the center of the bowl to the outer edge is 1 foot. Do you understand the problem? And the equation that models this is y is equal to x squared, where x is the distance from the center to the outer edge. From the center to the outer edge on the other side as well. Okay? Now, it says that on the graph, the radius of the satellite dish is the distance of 1 foot from the y-axis, and the depth is the distance from 1 foot from the x-axis, and there's a picture of it, okay, on the coordinate plane, and there's also a picture of it in 3D that we drew. It says the company needs to make new satellite dishes that have a cross-section 1 foot deep with a radius of 2 feet. So here's what I want. I want to take this and still be 1 foot deep, except this time I want the radius to be 2 feet over. So let's go over to the left, 2 feet over, and draw that dish to where it's a wider opening. It's a wider opening like that. Do y'all follow? What is a quadratic function that models this new satellite dish? Okay, do you see the hint here? What did I tell you? Do I have 3 points? If I want to come up with an equation for a parabolic curve that goes through this point, and this point, why couldn't I just do a regression like you just did on your homework check? Okay? Now, our calculators are in press test mode. Does that affect the regression? No. All I have to do is find the 3 points and enter those in. So where is the point here located on this new cross section of the satellite dish? Can y'all tell me the coordinates of that point? Anybody tell me what the coordinates of that point right there is? Very good. -2, 1. What are the coordinates of this point here? 2, 1. And then what are the coordinates of this point here? 0, 0. So let's come up with an equation that goes through those 3 points. Now, when you cut on your calculator, it's going to say, hey, you're in press to test mode. I know that. Just go to OK. Hit enter. Right? How do I enter a quadratic regression? Well, I got to go to a new document. So that's 1. Go to your home screen. Go to 1. I still add lists and spreadsheets. I go up and title this as my X column. Title this as my Y column. And then enter each point. X is -2. What was Y? 1. Then my other point was if X is 2, what was Y? 1. And then what's my last point? 0, 0. Now, this is just one way of doing it. We could do it with pencil and paper, but if we get to use technology on the test, why not use it, right? And then how do I come up with a regression? Go to an empty cell, wherever, it doesn't matter where you go. Hit menu. Then what do I hit? Statistics. Stat calculations. Oh, y'all did do good on the homework check then. Quadratic regression 6. And then title this as X. This as Y. And then go to OK or just hit enter. Okay, and then it plugged it in there. You see the quadratic regression? Did y'all's plug in? I got yours in there? So what's that equation? I don't know. It's kind of hard to see. You know how to see the equation really easily instead of going A, B, and C? Well, you know what A is. We know what B is. We know what C is. But we could actually just go straight to our graph. So add a page so we can look at the graph. Go to Control, Doc to add a page. And then add the graph, which is 2. Okay? And then go up. There's the equation. Okay? What in the world does 6.6 e to the -15 mean? Because it plugged it in there for you. What does that really mean? It means 0.00000000000000000000001 or 66. which is really 0. Anytime you got like a 6.6 and then e, that means times 10 to the negative 15th power. It's really so small that it's equivalent to 0. So really, what's my function rule? My function rule is y is equal to 0.25 x squared plus 0x plus 0. What in the world is 0x? That's no value. So what is it? It's just y is equal to 0.25x squared, or what's another way of writing that? 1/4 x squared. Does that make sense to y'all, or is that confusing? Your calculator sometimes makes calculations so minute that it's really equivalent to 0 in this. Okay, so if you get those, that's how you put it. Is that easy enough? Okay, let's look at the last problem then for today. What if the company from problem A needs to make a new satellite dish that's 1 foot deep with a radius of 3 feet? What's a quadratic function that models this? Well, just find the 3 points. So it's not 1 by 1, it's a 1 by what? 3 radius. So we got 1 foot deep, and then I go over 3 feet. Where would that point be? Would be a positive 3, 1, right? And then if I went over here and then to the left 3, where would that point be? If I went to the left 1, 2, 3, that's at negative 3, 1. And then where's this point? 0, 0. Got it? And then what's the function rule for this? That's all it wants to know. What's a quadratic function that models this? Well, let's do the same thing. Now look, we're going to do this from scratch again, from the very beginning. What do I do in order to do a quadratic regression? Come up with a quadratic equation that goes through these 3 points. Now you got to have at least 3. If you don't have 3, it doesn't work. What do I do? New document, my document, what do I hit? New document. Don't save my last one. Add a list and spreadsheet, which is 4. Title that as my X column. Title this as my Y column. And then go here and let's enter these points. What's my first point? Let's just do it from left to right. Negative 3 what? And then 0, 0. And then go to empty cell and hit menu. Statistics. Stat calculations, which is 1. Go do a quadratic regression, which is a quadratic equation that goes through those points. And then title this as X. Your Y list was titled as Y. And then just hit enter. And there it is. So what would this be? Y is equal to A x squared plus bx plus c. We put this in the standard form, not vertex form. So what is the A? A is a 0.11111111 that keeps repeating. X squared plus, what's B? 0x plus c. What's c if it's 6.6 e to the negative 15th? It's 0.000000, 14 zeros, and then a 6, 6. So it's roughly 0. So that's what y is equal to. But what if on the EOC you see these answer choices? Alright. Y is 1/10 x squared. Y is equal to 1/9 x squared. Y is equal to 1/8 x squared. And y is equal to 1/11 x squared. I don't see any of those. Right? That's not what we got as an answer. See, our answer is y is equal to 0.11111111 x squared. So which one's equivalent to that? How would y'all figure that out if you're taking the EOC? Huh? It's in the 1/10 because it's in the tens place. Well, that would just be a 0.1. not a 0.111111. So if it was a 1, you're right, it'd be a 1/10. So it's not that. How could I know? You could plug them in your calculator. Find out what 1/10 is. Watch. Now that's one way. So I just go to the calculator. And then just go 1 divided by 10. What's that? Oh, but you got to go 1 divided by 10 and control enter. I'm sorry. So it's 0.1. So I know that's not the same thing. Because this is 0.111 that keeps repeating. Then guess again. 1/11. So take 1 divided by 11. Hit control enter. That's 0.090909. So it's not 1/11. What would it be? 1/9. 1 divided by 9. Control enter. 0.11111 that keeps repeating. Now it stops because whenever we change it to press to test mode, it's got it rounding to so many digits. It's a float 6 or a float 5 or something like that. Okay? So, you're right. It should be B. My answer is y is equal to 1/9 x squared. Now, I'm going to teach you a little rule real quick before we move on that you should already know before coming here. But if you don't, let me show you something. If you ever have a single digit that repeats, 1111111, it's always 1/9. But what if it's a 0.22222222222? Guess what that is? 2 9ths. What if it's a 0.33333333? What, you see a pattern here? It's 3 9ths, which reduces because 3 will go into 3 one time, and it'll go into 9 3 times. So it's really 3 9ths, which reduces to 1/3. So what if it's a 0.44444444? You think it's 4 9ths? Let's see. What's 4 divided by 9? Control enter. It's 0.44444. 4 9ths. So what if I had 0.8 that keeps repeating? 0.88888. What would it be? 8 9ths. Last one. What if it's 0.666666666 that keeps repeating? It's 6 9ths. But 6 9ths reduces to, divide that by 3, they both have a factor of 3, to 2/3. But it's still the same thing as 6 9ths, isn't it? If I went 6 divided by 9, control enter. See, that's 0.66666, and it rounds it. It's stopping and rounding it to a certain place value. But really, it just repeats forever without an end. But your calculator is stopping it to so many decimal places. Does that make sense? Okay. So that will help you on some questions that you could possibly see. Now your homework for tonight is to do Math Excel. You got the rest of the class period to work on it. And it's Math Excel 8.3. There's only 10 questions. Show me you understand transformations by doing those 10 questions. I'll get to work.